Hi, this is James. This is my submission for the Project 14 Home Automation Monthly Challenge. So this is my diaper logger. We created this when I had my daughter, as a way to make it easier to indicate what kind of diaper she had. Because as you work day shift and night shift between the two, me and my wife, you need to know what's going on in there. So you can log a wet, a dirty, or a really dirty diaper. And we've got a LED on the front here to log the status. Okay, so I'll open it up and show you inside. Not necessarily very tidy in there, but this is what we've got. So here is the main board. We've got the Arduino Pro Mini and the ESP01, which unfortunately had very limited I/O, so that's why I'm using the pair of them. And then just a battery pack in here with 4 AAAs. So go ahead and put that back in there. And I will log a dirty diaper. So you tap the button here and we see it waking up, and it will go ahead and start connecting to the network. This is an RGB LED, so I'm actually using different colors to show the different shades. It's yellow now to show that it's connecting to the network. So it's actually turning on power to the ESP. It'll then connect over to the Wi-Fi network and establish communication to my server in the basement. And now we get the glowing green LED to show that it actually logged that diaper. Okay, so we can put that over here. And this is the PHP web interface, which I'm actually going to refresh, and we'll see right here that was the dirty diaper that we just logged. So then that makes it much easier. This will just sit on the changing table and we can keep track of what's going on with the kid. Okay, so this is a video that shows where I ended up on power consumption for my project. So I've got the board sitting up here, there's the container and the power pack down there, and I'm recording it with my meter. So the power is off right now on the power pack, so I'm at 0 milliamps. I'm actually going to go ahead and record this. Okay, so I will switch power on right here. And we get a small spike of 5 up to 180 milliamps, and then it goes back down to 0.1 milliamps. So we've done the initial boot up, and then it goes down into a deep sleep mode, so now it's just waiting on a button press. Okay, so I'll go ahead and I'll push a wet diaper here. So we flash our LED, and we go back up to about 160 milliamps, 170, 180. So right now it's actually joining the Wi-Fi network, establishing communication with the server, and logging the data. So shortly we'll see this start to flash green, which may not show very well on the camera. But now we drop down to like 2 milliamps when we're flashing green. And eventually that will shut back down. And we'll drop back down to 0.1 here in just a second here, 0.1 milliamps. Okay, so I'll go ahead and I'll stop this and we'll save it. And I'll go ahead and view the trend. And we can walk through what's actually happening in here. Okay. So right here in the beginning, we're off, and this first spike, this is where we power the device on, and then it drops down to 0.1 milliamps, and then we press the button and it jumps up to, up in here, 180, 240 milliamps, establishing communication, negotiating, sending the data back and forth, and then it drops down. Now this part at the end was a key component here. This is where it's flashing the LED. And we saw it was 2 milliamps flashing the LED. That was based on power savings using PWM instead of just turning the LED on and off, and also changing the clock divisor, which saves a ton of energy. And it's very hard to see, but right at the very end, that's when it flatlines just in this last little component here, where it goes back into deep sleep mode. But this section in here was flashing the LED at the end when nothing else is going on. So potentials to save power. I may be able to shorten this component up here where it's rejoining the Wi-Fi network. That was one thing I'd like to look at some point. But overall, the project worked out very well, and we were able to log our data. Thank you.